Thank you. Okay, so my name's Johan Janssen. Hello, everyone. I heard that you need a disclaimer with presentations, so I have one as well. Lego wasn't harmed, however, some Raspberry Pis died, but who cares anyway, there are more than enough of them. So what's a bit of the content for the next 45 minutes? It's around this. Questions were put at the end, but like already mentioned, feel free to interrupt me in between. I'll try and answer the questions directly. First, you might think, okay, why is this guy playing with Lego? And there are a couple of reasons. One, of course, it's fun, so you probably could have imagined that one. And the other reason was, we're a company where we build Java applications, Scala applications. We build those for large financial institutions, governments, etc. IoT is a big hype, and we were looking, okay, maybe as a company we want to do something in the IoT direction as well. But typically, IoT software is written in C, Python, or some other language. So if we had to learn that, it would cost us quite some time. So we wanted to figure out if we could use the languages and tools that we were used to and run it on IoT hardware, like a Raspberry Pi. Other thing is, it's nice for kids as well, to teach them more about programming and that it's interesting. And one of the funny things I found out was, it's also easy to explain concepts. For instance, if I try to explain to my wife what event-driven architecture is, and I say that it's sending message M from system X to system Y, she probably would have stopped listening at event-driven. And that's not her fault. I mean, she doesn't have the technical background that we have, and we speak some alien dialect that nobody understands. But if I told her, like, okay, I send a message from my laptop to the computer on the train to instruct it to play a song, then she can fully understand it. And basically, I'm saying more or less the same thing. So it helps to explain some concepts as well. If you are thinking about starting with it, be careful, because you might end up with a living room like this. This was only the beginning. I have to say it got even worse than this. But it's pretty easy to get started. So, question for you, who has a Raspberry Pi? Okay, keep your hand in the air if it's collecting dust on a shelf. So, okay, now you know what you can do with it. Because to do this, you need a Raspberry Pi. If you already have a Raspberry Pi, it will probably cost you 25 bucks for the ingredients. If you have to buy a Raspberry Pi, it's like 50 bucks. So it's not really expensive. You need a USB Wi-Fi dongle, you need a battery pack, and you need an infrared transmitter. And where you need that for, I will explain in a minute. But you can do a lot more. This train has a speaker, so I can scare burglars away, or just my kids. When I'm at work, of course only during lunchtime, I can play with my trains. There is an RFID reader to determine the position on the track. It's like the OV chip card, which we have in the Netherlands, with the card which we use. That's also RFID, basically. And there is a full HD camera on top of the train, so I can have a live image feed from my train, which is of course really useful if you're not in the same room as the train. So what I use from a Raspberry Pi perspective, in the trains I use the Raspberry Pi A+, because they're relatively small and they don't consume a lot of power, so I can run them longer on a battery pack. At that time, the Raspberry Pi Zero wasn't available. If I would do it again, I would probably pick the Raspberry Pi Zero, because it's even smaller and consumes even less power. If you're not on a USB battery pack, but just on power from any outlet, it's probably advisable to use a quicker Raspberry Pi, because it enables you to develop quicker and run things quicker. To start a Spring application on a Raspberry Pi A+ took like 2 to 3 minutes without tweaking, so that takes quite a while. Architecture, I don't know if you're familiar with this, but if you buy Lego bricks, you cannot buy them a piece. You have to buy them in a basket like this, and they're round, so it's really annoying. You cannot easily put bricks in it, and I'm Dutch, so I want to put as much bricks in it for the value that I pay. So I end up with this. I didn't need those bricks, but I mean, you pay for it. When we started, we built basically this setup. LTCC stands for the Lego Train Control Center. We had an Angular front end. We had a Java backend. Both of these were running on my laptop. We used REST. This, by the way, is the international symbol for REST, but you already recognize that, of course. Unfortunately, none of my colleagues got it, but okay. then I had some applications running on the Raspberry Pi. So I have a device control applications which runs on the train and for the Ferris wheel, and I had a switch control to control the switches. And underwater, I used some C and Python libraries that were already available, and I tweaked them a little bit to my needs. So Java was merely like an integration layer and a communication layer. And I used the Raspberry Pi web interface for video streaming, basically. That was all nice. It was working perfectly, but we had a Scala and Akka course, and we were really excited about Akka, but we wanted to try it in something more than Hello World. So we decided to throw away everything that we built in Java and build from scratch in Scala and Akka. I will show a bit of Akka later to get you a bit more understanding of it. But the biggest change was that between the different the different Scala applications, so this one's running on my laptop and this on the Raspberry Pi, we no longer communicate with REST. We use remote actor communication, which is Akka over TCP. So no HTTP calls anymore. We use a more low-level approach. That was the biggest change. But to go to the outside world, we needed some REST endpoints, for instance, for Angular and for the RFID library. From a hardware perspective, we started with everything wireless until we put this on a booth in our first conference, and Wi-Fi basically didn't work because there's too much Wi-Fi in conferences. So we ended up putting everything on wires that we could wire, except of course the trains, because it would look silly if you have a wire going at the back of the train. But the rest, the cameras and everything, it's simply wired. So everything is connected to a router, and we then send commands wireless or through the wire to the Raspberry Pi, and then the Raspberry Pi uses this infrared transmitter to control the infrared receiver from a Lego train. So this is standard Lego. I can show you with Wally. So this, everybody recognize Wally? So this is just standard Lego, which I automated a little bit. This is the infrared receiver. We have two different engines, and we have a battery pack at the front. This is the default Lego receiver. They have two different ones. That's the other one, but they work the same. So you can simply, if it works, move it around. And this works quite nice until you have a distance of around 2 to 3 meters, then infrared doesn't work anymore. So you cannot control Wally anymore or your Lego trains. So to come up with a solution, I came up with this, a simple Raspberry Pi, USB Wi-Fi dongle, and an infrared transmitter. So now I use this little infrared transmitter to send the same signals as the infrared transmitter from Lego was sending. So I didn't need to change the engines or anything. I could just send some other commands to it. Of course, sounds, like I already mentioned, a train needs to make train sounds. I wanted to determine the position on the track where the train was running, so I used RFID cards, the small ones, on there. And I used the camera. But camera was really tricky. At first I wanted to do video streaming, but with the Raspberry Pi that's difficult. And in the end, I found an application that doesn't do video streaming, but it refreshes pictures really quickly. You cannot really see it, at least I cannot see it. Maybe if you have really good eyes, you can notice it, but it looks real time and quick, but it's just images being refreshed at a really high speed without a delay. Because if you would have used video, you would have had like a 5-second delay of your video, and then the train is already across the track another time, so that's not really useful. If you do something with Raspberry Pi cameras, really look up this program. It works really well. It does motion detection and stuff like that as well. We also wanted to automate the track switches. If you're a bit older, like myself, maybe you know the older Lego where you had automated track switches and everything. They don't do that anymore. They don't have automated track switches anymore. So you just have a switch with a yellow lever. So we bought some servos. We bought a large adapter because they consume quite a lot of power, and a special servo adapter board for the Raspberry Pi. And with it, we could control these switches. But it was quite hard to do that because these paper clips, you need to bend them at the exact good length because they would, either the switch wouldn't open or wouldn't close. These are probably the 4 most expensive paper clips in the world because we worked on it with 3 colleagues for half a day before it worked. And it's a bit brittle, so I don't take it to conferences anymore. it's a bit hard. But this is one of the few solutions that I've seen where you didn't have to fiddle with the Lego. I saw other solutions where people drilled something off of the Lego to make the switches go smoother. But if you tell that on a Lego forum on the internet, those people will hate you forever. So don't do that. I thought trains, of course, were awesome. But when I saw the Ferris wheel of Lego, I was like, OK, I need to have that one as well. So I bought one, and then I was like, OK, I'm going to automate that one. And it actually was really simple, because it's the same infrared receiver as I use in Wall-E or in my trains. So I could use the exact same software I was running on my trains and run it on another Raspberry Pi. So that was really easy. Then every IoT project, I mean, you need to do something with LEDs. And I thought the Raspberry Pi was a bit overkill to control a few LEDs. Because what I wanted to do was display the speed of the Ferris wheel. So here it's moving at speed 3. And the different trains on LEDs. So I ended up not using a Raspberry Pi, but a particle photon. Who's heard of the particle photon? Okay, a few people. It's like an Arduino, but then with a Wi-Fi chip on board, and they have their own cloud environment. So it's if you buy one, you connect to it with your smartphone, enter your router credentials, and it's in the cloud. Then you add a little bit of software to the web interface IDE, which is basically here. So you program Arduino code, and you can flash it on one of the different particle photons that you have, and then simply call them. It works really nice, and it's only like 25 bucks, but you cannot run Java or Scala on it, so it's a bit more low-level stuff. But I can really recommend it if you want to do something which doesn't need lots of computing power. I had a lot of fun with these things. You're, of course, already wondering for like 15 minutes, like, when are the trains going to drive? So let's do a demo. So this is the Angular application that I created. You can see the video over here. That's from the camera that's on the boxes at the back and the right. I disabled the camera on the train for now, because sometimes if the Wi-Fi, the conference is a bit, there's too much interference. I don't have a live video stream, and the video stream is also blocking my commands that I send to the train. So then I also cannot control the train. So for safety reasons, I simply disable the camera for now. So I can make the trains run any direction, basically. Ferris wheel. OK, that was nice. Nice crash. It's a demo, so you need something that goes wrong. We had that. At the top right, you can see that these ones were used to control the track switches, so either go forward or bend with the track switch, and every track switch had a Lego minifigure on top of it, so I could distinguish the different ones. Let them make a little bit less noise. I cannot see it properly, but I think you see 3 dots going clockwise now, because the Ferris wheel is going at speed 3 forward. If I now make it go backward, it should go with 4 dots backwards. So now I can see with the LEDs what the speed of my different devices is. For the trains, you see maybe 3 dots there. I don't know if it's really visible. I can increase the brightness a bit. So now you see 3 dots. I will decrease the brightness a bit, because probably you get annoyed by it. But and over here, you can see where the blue train is. So it's now at the cow, the car, the bicycle, etc. And there's only one feature that we missed, and that's the sound. So let's make sure it makes some noise. So basically, you can play any noise, simply train sounds, or simply try to scare someone away. Of course, it doesn't work now. But you can play any sound, basically. It's just MP3s which are running on a device. I'm a bit confused why it doesn't work, but OK. So this is easy. This is just manual control. We're sending some commands to the train, and they're being executed. So like, OK, that's cool, but can we make it a bit more advanced? And what we did then was create autopilot stuff. So we can simply send a set of commands to the train. So that was the one I was waiting for. So you can use any sound to scare burglars away, anything. Just have fun with your kids or your wife or husband. So in this case, I send 3 commands to the train. First, I say that the train has to drive at speed 3 for 3 seconds, then it has to stop for 3 seconds, and then it has to play a song. Let's try that one again, because it should first drive. No, let's not do that. Of course, you always see that something. Well, listen. The infrared transmitter was going upwards, so then it doesn't receive any instructions to the train. So now it drives for 3 seconds, stops for 3 seconds, and then should play the song, but it's already playing the song. Okay, so these commands are sent to the train, and I can shut down my laptop and it will just continue running these commands. So that's okay, but we wanted to have something a bit more advanced. So we want to do something location-based. So what we now do, there is something wrong with my icons. Probably I've run an update which I didn't check that all the icons were working, but it's simply buttons to add something, to play something. So what I'm typing here is that if the blue train reaches the bicycle, then the Ferris wheel will move at speed -3. If the blue train reaches the cow, it will start moving at speed 3. Let's do something more, speed 2. The crossing, and open another screen for this one, and make the blue train moving. So it's now at the bicycle. Did I play this one? Probably not. So now it's at the crossing. It will move at the speed that I gave it. 2. At the cow, so now it's moving at speed 3. Bicycle, so speed -3. So this way I can interact between the different devices. I can even say that if the blue train reaches the bicycle, that it should reverse, or anything else that I would have wanted. Okay. So that's in short how it works in a short demo. Because I also wanted to explain something more, not just have fun, but also try to learn you something new. Who already worked with actors in Akka? Okay, a few people. So the first few slides, you probably are quite familiar with it. After that, we are going to talk on some other subjects. So just stay seated, and you probably will learn something new. So what's an actor? An actor basically is something that receives messages. You extend the actor, and you define a receive method, and in this case, I simply print everything that's sent to the actor. I create an actor system, I retrieve a reference to the actor, so the worker actor I defined here, and I can send a message with the exclamation mark. So I simply send a string here, and the string is being printed. So nothing fancy going on there. The nice thing is that working with those actors locally, so within one JVM, you can communicate with different actors with each other, but you can also communicate across JVMs. So I have an actor running on my laptop, and I have an actor running on my Raspberry Pi, or even multiple ones. And I can communicate with them. Normally, you would need to have REST endpoints for that, or you use SOAP or something like that to communicate. With actors, it's a lot easier. So in one of the previous slides, you saw that with this, we retrieved the actor reference, so we could send a message to it. If we want to send a message to a remote actor, we simply have to specify the IP address, port, the name of the actor system, and the actor name. Here I put it all in the code, but you could put this in the configuration as well, but I wanted to make a simple example for all of you. So this is everything you need to send a message across different JVMs. That's a lot easier than REST. And nowadays, you have lots of discussions on monolith versus microservices. And some people say, okay, start with a monolith, and if it's too big, create smaller applications out of it. But if you want to do that, you need to define all kinds of REST endpoints, communicate with those REST endpoints, and it's basically all boilerplate code. It's nothing business related. If you have a monolith in Akka, you can simply extract parts of it and use those as remote actors. So it's a lot easier from a refactor standpoint. You need a little bit of configuration, but this is basically copy-pasting. You enable remote actors, the IP address and the port. So if you run multiple applications, you probably want to run them on different ports, but it's fairly easy to do. Something you need to do is you need to define what messages you send from one JVM to the other JVM. So if I want to send a play message from the actor on my laptop to the actor on the Raspberry Pi, I need to define those messages at both sides. I could have sent a string, but a string is not really the recommended way of doing this. So what we did was we created like a shared library called message protocol where we define all the messages, and we use that library on the laptop and on the Raspberry Pi. And it's really simple. This is basically everything for the music service. We define a case class play, which simply gets a file name. So here I can say which file I want to play, and here I can retrieve a list of file names, and that's everything. And if I want to use that in my application, I can simply say, okay, use the package name where that music service message, which we saw in this slide, is being located, and simply send those messages between my JVMs. So we really liked using Akka and using remote actors. Like I said, you don't need to convert to JSON or create REST endpoints. It felt more natural. Although, of course, HTTP has some advantages. It's independent of technology. You can create a service in C# and connect to it with a Java application or a Scala application. If you have remote actors in Akka, you can only communicate within the JVMs. You cannot communicate with another system written, for instance, in .NET. There is Akka.NET, but you cannot communicate with it directly. So it's a bit more dependent on the technology. HTTP is a bit less dependent on it. And HTTP is a bit more loosely coupled. You can change parts without, for instance, on the server side without having to change the client, etc. Okay, so we were really interested in it, but we were like, okay, how can we convince people to use it? I can say I like it, but I don't have blue eyes, so you probably don't trust me on my eyes. So can we get some hard numbers on it? So at first we tried to see, okay, is there a mismatch or a big difference in the number of dependencies that we need for it? So we created fat jars, which basically is a jar including all the dependencies that we need, and these were the sizes. So here you can see that when we use remote actors, it's a lot smaller than Akka HTTP, but it's still quite comparable to Spring Boot. So no clear winner here. It's not really a winning point for Akka. So then we're like, okay, can we do a bit of performance testing? Who's used Gatling already? Okay. Who of you have used JMeter or some other tools? Okay. If you have used JMeter, you have a new project where you need to do performance testing, have a look at Gatling. I've started with JMeter myself, but I like Gatling a lot better. It's more intuitive, more easy, if you ask me. And it's even so easy that I'm going to try to explain it to everyone here. So this is the scenario that I used. So I create a scenario with a name, and I say that it has to be repeated 100 times. So this is basically a loop of 100 times. I basically do a GET request, and I check that the return status is 200. And then I do a pause between every request. Here I say I do a ramp up of users, so I will get 1,000 users over 10 seconds. So after 5 seconds, I will probably have around 500 users of my application. You can vary this, of course. This is just the numbers that I picked. So 1,000 users will execute this loop 100 times. So that's basically everything you need with Gatling to have a simple test up and running. So what are we testing here? The left side is the same for both scenarios. So we have Akka HTTP endpoint, but at the top, we connected to another Akka HTTP endpoint in another JVM, and at the bottom, we connected to Akka remote actor instead of Akka HTTP to try and see what the difference is between communicating through REST and with remote actors. If we then look at the mean response times in milliseconds, we can here see that with 50 users, it's almost the same. But if the number of users go up, remote actors perform a lot better. They are a lot quicker. The same goes for the max response times. I mean, this is like 8 times as much for Akka HTTP compared to remote actors. I had a graduation student that also did research on the performance of Akka, and he tried out a setup which was quite similar but not exactly the same as I had. And he figured out that REST could handle around 600 users, but remote actors could handle like 3,300 users. So that's the difference between either buying 1 server or buying 5 servers. So from a hardware perspective and a business perspective, that's also a good business case. So quite easy, you would say, right? But I thought, okay, maybe I have to compare it to some more traditional software that we're more used to, like Spring Boot. Another joke most of the people that of my colleagues didn't get at first. I tend to use pictures that nobody understands, but I found it was a nice picture. The unfortunate thing was that Spring Boot was faster if we look at the mean response times. And of course, I could have falsified these results, because never trust any results you haven't falsified yourself. But I tried to make it nice and not fiddle with my results. Although I did a little tweak with Spring Boot, if you use the REST template to call a REST endpoint, that doesn't perform at all. Some people even say it's not production ready. So I replaced it with an Apache connection factory and got a better performance with it. That was the only tweak I did. And that was only because else I couldn't handle more than 300 users. So it already broke down around here. For the rest, I kept everything the same, just default settings. So unfortunately for my story, it didn't end up that good. But then I looked at the max response times, and to my surprise, that the more load the application was getting, the better the remote actors were performing. And that's because REST was consuming a lot of memory and a lot of processing capacity when handling lots of users, while Akka is scaling a lot better with a higher amount of users. Of course, I mean, this is one check. It might differ for your applications, but I think Akka is really something to consider if you want to build highly concurrent, fault-tolerant systems, because they can perform likewise as HTTP applications, or maybe even better, depending, of course, on your setup. Okay, something about the challenges. This isn't my house, unfortunately, because else I would have probably had a good insurance. But I've burned down some stuff. I read a manual on the internet on how to connect the infrared transmitter. I connected it, got something to drink, and came back in my room. Was like, hey, it smells weird. And then I tried to touch it, but it was really hot, so disconnected it. And that was my infrared transmitter. Luckily, most of the hardware I use is relatively cheap, so if you burn something, you just get a new one. The only disadvantage is mostly it comes out of China and it takes 4 weeks to get a new one. So if you go try and play with this, buy a few extra ones so you can just continue on playing. Hardware resources. With my Java application and some other applications running on the Raspberry Pi A+, I reached the limits of the memory. So it still runs, but it's just running. It doesn't have much room left, and that's because I use an A+ Raspberry Pi. If you would have used the 0, it has twice the amount of memory. So with a new Raspberry Pi, I wouldn't have any issues at all. But it's something to take into account, that it's not as unlimited as your laptop or your desktop at home. It's a Raspberry Pi. Raspberry Pi connectors. So I made a complete setup, everything worked, and then I started using the Raspberry Pi A+, and inserted a USB Wi-Fi dongle. I would say, that's simple, okay, it works. So I connected it, didn't work. Connected another one, didn't work. And then the third one, I first connected to my television screen, it worked. Inserted the USB Wi-Fi dongle, it didn't work anymore. So I pulled out the USB Wi-Fi dongle and I looked into the connector, and I saw that the pins that normally keep your connector fixed, they were bent like this because it was stuck in it. And that's basically the end of your Raspberry Pi, apparently because they use cheap connectors on a Raspberry Pi A+. So if you use an A+, first use a screwdriver to push the pins a bit up, and then insert your USB Wi-Fi dongle. I really like Lego, but I don't like the way on how they work with batteries. Batteries are really, you have to use non-rechargeable batteries, because then it works. And if you use rechargeable ones, even like famous brands, they often don't work, or some of them work and others don't. So the battery pack is really picky. RFID as well, so you see here that the RFID cards, they're quite close to the reader, and then it goes well. But if my train will speed up, then it won't catch it anymore. So you can then either buy more expensive RFID readers, because some of them, they even have power, so they can send a stronger signal, or find another solution. But for me, this was a cheap solution, which is working perfectly as long as I don't drive the trains at high speed. We've had a few Wi-Fi issues. Wi-Fi at conferences, 2.4 gigahertz was awful. Everybody was using it, and I couldn't use 5 gigahertz because 5 gigahertz USB Wi-Fi dongles for Raspberry Pi have really poor support. Luckily, being lazy pays off. Now everybody's moving to 5 gigahertz, and I'm still at 2.4 gigahertz, so I'm getting better and better with my reception of the Wi-Fi. But all in all, it's not really plug and play. It took me quite a while to set up everything. I often get the question, how long did it took you to set this up? And I honestly don't know. And even if I knew it, I would probably not tell you, because then my family would hate me forever on playing too much with Lego. Because there are so many options. When I started with this, I wanted to use Docker, not for a real good business case, but I mean, I like Docker and wanted to run it on a Raspberry Pi with my trains. But back then, there was Arch Linux. I had Docker running on it, worked perfectly, just a few commands, and it was running. But all the modules and stuff I needed to use for the infrared transmitter and everything, there was not really documentation or software for Arch Linux, only for Raspbian. But Raspbian had really poor Docker support. You needed to cross-compile everything. So in the end, I just thought, okay, I don't really need Docker, so I just threw that requirement away and could just continue. And nowadays, Raspbian has better Docker support as well. So if I would have started again, I could probably achieve it a lot easier. But there's lots of documentation, and not every documentation is right, I found out. So I connected some stuff the wrong way and burned some stuff. Takes a while to set up everything. And Lego with children, you would think it's a good idea. Except if your children are like 3 years old. Then you need to get it away quickly out of the room after you played with it. But for me, the biggest challenge probably was time, because you keep on playing with it, you keep on inventing more stuff, and if you think, okay, it's just a sensor, I just connect to it, and it's done in an evening, that never happens, because you have either issues with the hardware or with the software, and you don't know where the issue is, because you first have to figure out if it's a hardware or a software issue. So it took me a lot more time than simply programming, because if you're programming, you write a unit test or you debug and you're done. Debugging a combination of hardware and software is a lot harder, I found out. Maybe you're thinking, okay, this looks nice. Can I do it myself? And actually, you can do this yourself quite easily. I recently released the software, not the Akka and Scala part, because I think that's a bit hard to set up if you're not used to Scala and Akka. But I built a new setup using Spring Boot, and it's running on here. So there's a really small, let's see if I can show it to you. At the bottom here is a Raspberry Pi Zero, so that's a really small one. For the rest, the setup is basically the same as on my train. Let's see if I can get everything back in here. Again, there's an infrared transmitter with an infrared receiver. Let's see if I can make it drive around. So what I did was I created basically one repository with 2 applications. LCC install script is the Lego Control Center install script. It installs all the dependencies that you need, all the software that you need. And LCC is a simple Spring Boot application that exposes a REST endpoint with which you can control a car, a train, or basically anything you would want to control. We see the camera feed. Unfortunately, it's now looking at something that's not really interesting. Let's see if I can make it move a little bit. So, I mean, this is a really simple REST interface, which I intentionally did. I didn't want to make too fancy stuff. Oh, okay, it crashed. But this is to give you a simple idea. I mean, if you download this stuff and you buy a Raspberry Pi and the infrared transmitter, you're good to go, basically. Okay, thanks for putting it in the good direction. Let's see. Oh. Can make it go a bit to that direction. So this is just simply executing a few REST commands. Of course, I could have created a nice interface or control it with a steering wheel or whatever, but that's up to you. You can make it. Okay, I'll stop it. So with this, you can create your own front end for it by just doing REST calls and just have fun. So for the conclusion, I mean, I think we achieved what we wanted. We got a lot of experience with running our normal software on a Raspberry Pi. And we learned that it was perfectly possible to run Java or Scala applications. You sometimes have to be a bit patient when it is booting, but when it's running, it runs perfectly. Commands are received almost instantly. You don't really notice a delay in it. And we learned a lot from it, because later we did projects for customers where we used this software again. And then we already had experience with Scala and Akka and everything around it. So it seems like fun, but we learned a lot of useful things from it. And I can really recommend to do something like this if you want to try out a new technology. I could have written Hello World with Scala and Akka, and probably that would have worked, because if a framework doesn't support Hello World, it's probably really crappy. But if you want to figure out how a framework is working, and if it's useful for enterprise products, you need to write more than Hello World. And then, yeah, I advise you create something cool out of it, and something that can grow bigger and bigger, so you can experiment more and more with it. So for us, it was really useful. Learned a lot from it, got a lot of attention from it. Kids like it. I got to all kinds of nice places, although Amsterdam, for me, being from Holland, isn't really that adventurous. But it brought me basically all over the world.